Okay, let's start at the beginning. You are learning how to do inverse trig, and so as opposed to normal trig, this has some restrictions on it. So if I go like this, inverse sine of 1/4, you need to rewrite it right away as a normal sine problem. So everybody try that one. And then try to remember that when you draw a triangle for it, you're restricted. Remember how inverse sine has restrictions? It's only allowed in certain places? All right, so here's my, actually I should rewrite it for sine of theta equals 1/4. Is there a problem with the opposite side and the hypotenuse side? Like, is the hypotenuse like messed up? Like, you're not allowed to have a hypotenuse that size? So this is the opposite side, and this is the hypotenuse side, right? So if that had been reversed, do you get that this answer would have been undefined? Because if it had been 4/1, you'd say, wait a minute, the hypotenuse can't be 1 where the other one's 4. That's impossible, and you said, oh, you would have said undefined right there. Okay, but back to this one. This one is okay. It just means I'm not going to know necessarily what that angle is, like off the top of my head. All right, so let's keep going with it, though. So inverse sine is only allowed from here to here. And remember, that's from -pi/2 to pi/2. Okay? So now, I can't use this and I can't use that because of that. So now, where is sine positive like it appears to be here? Well, only up there in the all area, right? So I can't use that either because sine's not positive down there. So now I'm doing opposite over hypotenuse. This is opposite, this is hypotenuse. Do I even need that other sine, that other side, I mean? Do I need this side? No, I don't need that side. Okay, but now I'm left with, what am I supposed to be telling them? An angle or sides? An angle. I'm supposed to figure out this angle right here. And I can't figure out that angle right there, at least not off the top of my head. Now, we aren't going to give you any this hard because we'd only give you ones you'd recognize, like 30s, 60s, 45s. But I want you to know a problem like this can be done, and that's exactly what the button on your calculator is for. Okay, so if you've got a graphing calculator nearby, take it out, and let's just show you one of these so that you can get how this works. Inverse sine of, that's this part right here. We're going to type this right here into the calculator, except I wouldn't type in 1/4 because you have to parentheses around it and all that. What would you use? 0.25, very good. So inverse sine of 0.25. Now, let's see. Inverse sine is right above sine of 0.25. And it comes out, it depends on which mode your calculator is in. Everybody, just for a second, go to mode and see if you're in radians or degrees. And I'm going to take a quick poll. Those of you that just typed that in, hit the mode thing to see whether the answer it gave you was in radians or degrees. Hit the mode button. How many of you are in degree mode? Raise your hand if you are. How many of you are in radian mode? So almost the whole class was in radian mode, but there were like 3 people who were in degree mode. So the point is, if they get one answer and your friend who types in the same exact thing gets a different answer, one of you's probably got radians, the other one's probably got degrees. All right, so I got 0.25. Who else got 0.25 when they typed that into their calculator? All right, and that was the answer in radians. Who had a different answer for degrees? What did you have in degrees? 14.47 degrees. Is that 14 point what? 14.5 if I round it? Okay, good. So 14.5 degrees versus 0.25 of a radian. They're both right, just one's in radians, one's in degrees. All right, so these can be answered. You can get this answer. It's a quarter of a radian. Okay, but you're not going to be usually doing that until we get to our word problems. And our word problems, when we learn that, which is coming next after this next test, then you're going to be allowed to use the calculator to figure some stuff out like that. Okay, yes? No, the calculator on test tomorrow would make it way too easy. You'd be able to do everything by going inverse sine of 60, and then it would just tell you answers. And we want you to get it without the calculator. Just so you know, on a lot of the stuff that you're moving into, calculators are only allowed half the time. So we gotta well, that's why a lot of our tests are like that. We have a lot of no calculator tests and some with calculators. So you gotta be able to do both. I like this way of doing it better than where my kids go to school. My kids go to school in a place where they don't let them have calculators ever. And I think there are good things you can use the calculator for. There's patterns you can explore. There's we allow them sometimes, and I think it's a good compromise. If you allow them all the time, then some people really just won't ever learn simple multiplication because they will not even trust themselves to do 9 times 8 anymore after a while because they'll just always do it in the calculator, and that's not good either. So I think we're striking a decent balance there. All right, so let me change this problem just a little bit. I'm going to go back to the original. And what we learned next was, what if we had this, but then we do sine of that? So draw the picture, do the same exact thing. I'm going to save some time and I know it's got to be here because I just did this one before. You start in the middle, right? And then opposite, hypotenuse, and then this other side. Do I need the other side? No, I don't. You know why? Because I don't need adjacent to do a sine problem. So has it broken any rules here? Is there anything undefined or impossible about this? No. So this all came out fine. I don't know what the degrees was, but I never even need to know because the final question is, what is the sine for that triangle and that angle, I should say. Sine of that angle is 1/4. So this is one of those ones where this would have canceled that, and the answer is 1/4. It's really hard to know whether you're in that kind of triangle or not, whether it'll work or not. Let's do another one like that. Inverse sine of 3 pi over 4. Sometimes they'll cancel. Sometimes the thing will fail. Sometimes there's an answer, but it's not 3 pi over 4. So don't just assume, well, I think it cancels, and so it's 3 pi over 4. You're going to get it wrong more often than you're going to get it right, because we usually test you on the weirder exceptions, not just the simple ones. At least if it's going to be a harder level like our 3 question. All right, do you remember where 3 pi over 4 is? That's 3/4 of a pi. That's over here. That's this side. It's right there. That's where 3/4 of a pi is, that spot. Okay, so sine in that triangle. Well, I need to know what kind of triangle it is so I know what the sides are. Well, if it's got fourths of pi's, 1/4 of a pi is a 45, that's a hint that that's probably a 45, and it is. And so that makes this a 1 square root of 2, but one of those numbers is wrong now. Which one? You got a negative right there. Good. Okay, got the triangle drawn right? So what is the sine in that triangle? Sine is opposite of hypotenuse, right? Opposite hypotenuse. So it's 1 over square root of 2. Now I want to even tell you, I'm going to admit that last hour I made a mistake, and I thought, wait a minute, this one's not allowed. Because I thought inverse sine, see, inverse sine out here is only allowed from here to here. But why shouldn't I look at that? Because I'm on the inside. I have to finish on the inside before I even look at what's on the outside. Okay, otherwise that could get you. It got me. So I shouldn't be looking on the outside until I'm done. Now that I'm done, this is gone. And now the answer to that was this, 1 over root 2. So the new question now that I can consider, now I can start looking. I'm going to erase this picture too because it's like you're starting the problem all over again. Now I have to do inverse sine of 1 over root 2. So now I'm going to rewrite that. Sine of theta equals 1 over root 2. And then I start it all over again. Now this time, I should say, where is inverse sine allowed? Because now I'm doing the outside part that has the inverse on it. So now I should be thinking about that. Inverse sine is only allowed there and there. So I'm crossing off this, crossing off that. Sine is positive. See, there's no negative there. So therefore, I'm crossing off that. And now I must be in here. And sine is opposite over hypotenuse. Opposite hypotenuse. The other side's 1. Can you recognize the angle there? Which angle is it? And that's 45 degrees or pi over 4. It is one of those where it would cancel and give you the wrong answer. See how if I'd have gone ka-doink, it would have been 3 pi over 4, and that's not right? Why? Because when you're doing an inverse sine problem, you wouldn't be able to have an answer like that. It's outside the range. But anyway, if you just stick to going from the inside out, it all works out fine. That's the one thing that keeps coming back over and over again. You got to start on the inside, finish that, go to the outside. All right. Now there's a lot of them that I could put on the board and it'd be really easy for you. I'm trying to show you the kind of weird exception kind of things today because that's like it's your last chance to learn new stuff here. So, all right. Here's another one that, you know what? I think I actually feel like I should give you a fairly normal, easy one so that you can build up your confidence again. So they're not all weird exceptions today. So let's try another one. I'm going to go cosine of inverse sine of root 3 over 2. That's a typical, normal problem. I'll pause for a second while you're working on that. Okay, I'm back. Let's see. First thing I'd do is start on the inside. Then, since I'm on the inside, I should probably look at that inverse and try to rewrite it. Sine of theta equals root 3 over 2. Am I breaking any rules or anything yet? Okay, next thing I got to do is draw the picture and see where that's allowed. Since I'm doing an inverse, I should use these restrictions. Inverse sine's only allowed from here to here. And so I can't be here and I can't be there. Sine is positive, so it can't be there, and I must be here. And sine is opposite over hypotenuse. Opposite square root of 3, hypotenuse is 2, and that must be a 1. That makes this a 30, that makes this a 60, and that makes the answer not 60, but pi over 3. Am I done with the whole problem? No, I just did the inside, though. So the inside's pi over 3. So now I'm going to get rid of all that, and my new problem is cosine of pi over 3. I'm just going to rewrite it. Cosine of pi over 3. It's like you start a whole new problem. Now I don't have to do anything with inverses or anything. It's just a cosine of pi over 3. So now where can that be? Well, where is pi over 3? It's right there. It's like a 60-degree angle. And then I'm going to draw my picture. Cosine's adjacent over hypotenuse. And I know if this is a 60, that this must be a 30. That makes this a 1 and a 2 and a square root of 3. And what angle am I at? No, that's not the question. I've got the angle. What I'm supposed to figure out is two sides. What over what? What is cosine of pi over 3? 1/2. How many of you had 1/2? Awesome. Good. That's a nice normal one. Now let's do another weird one. Okay, so let's say you have inverse cosine of 1 over x, and I'm supposed to do sine of that. Okay, well this is weird because I didn't give you any sides. I told you they were 1 and they were x. And that means you're going to have to draw a triangle and not label the sides with numbers, but you have to label it with like x and 1. And one of the sides is going to be like square root of x squared plus 1 or something like that. Figure out what the third side is in that triangle. I'll pause for a second while you try that one. Okay. First thought, start on the inside. Cosine of theta equals 1 over x. Then you draw your picture and you say, where can I be? Inverse cosine is only allowed from here to here. Did you catch that? Cosine's different. All right. Inverse cosine is only allowed in there. So I'm crossing this off, crossing that off. Now, where is cosine? Well, it's hard for me to know which of these two I should draw it in because the x could be negative or could be positive. I don't know. I'm going to default then, and I would recommend you default back to the standard position here. And now I'm going to ask myself, what are my side lengths? Sides are opposite in hypotenuse. Cosine is opposite of hypotenuse, right? So opposite's 1. Oh, wait, I did that wrong. Cosine isn't opposite of hypotenuse. You let me do that. adjacent over hypotenuse. The adjacent side's 1, the hypotenuse is x, and then we need this side over here. That's a big square root of, and it has to do with x squared and 1 squared. Do I add them or subtract them? Good. X squared is the big one minus the 1 squared. We could write 1 squared or just 1. Probably be better to write 1 because it's simplified. Now, some people think you could take the square root right now. You cannot. Leave it alone. The square root of that is not x plus 1 or x minus 1. You can't do it. So leave it alone. That side, the opposite side, is that. Don't try to simplify it. So now, what's the final question? Sine in that picture of that angle, sine is opposite over hypotenuse. There's the opposite. There's the hypotenuse. Root x squared minus 1 over x. Raise your hand if you had that one figured out. It's more than half. Nice work. Okay. That's a tough one, I know. That's one of the weirder ones because it has the sides where you don't know how long the sides are. All right. I think that's enough practice off of me making problems up. Now I'm going to give you the review, and we'll do a couple of these together. I strongly recommend doing all of them and checking them with the key tonight. Some people, I think, get overconfident because they see me doing them and they understand them because I'm doing them. You need to do them yourself and have these weird things happen and decide, is this one of those undefined kind or not? By the way, an answer on the test of undefined, if you don't back it up why it's undefined, you won't get the credit. Like if it's undefined because you're outside the zone where you're allowed to be, you should say that. Or if it's undefined because the hypotenuse is smaller than another side, you should say that. Give me why is it undefined, because otherwise it'll be too easy for kids to just cheat, look at somebody else's paper and see that the answer is undefined and not even know why. So don't just write down undefined without supporting it with a why. All right, let's look at number 1. Yes, showing your work would help, but you need to like show where the part was that told you, okay, this part shows me it's undefined. This part shows me it's impossible. All right, number 1, arc cosine of root 2 over 2. I'm going to write it as this, inverse cosine. It's the same exact thing, of root 2 over 2. And then I would start by drawing, or rewriting it, cosine of theta equals root 2 over 2. And right away we face you with a triangle you're super used to. It's not the normal 30, 60, 90 or 45, 45, 90. It's something adjusted. These numbers, do you recognize them though? Is that the 45, 45 or the 30, 60, 90? That's the 45, 45, 90. And why? Because in case you forgot, it was 1, 1, root 2. And if you multiply them all by the square root of 2, it becomes the root 2, and root 4, which is also known as 2. So root 2, 2 triangle. And that's this guy right here. So I know I'm in a 45. So I'm probably getting an answer of 45. But I'm going to finish it. I'm going to draw a triangle. I would recommend you do that too. Cosine, inverse cosine is only allowed here and here, crossing off, crossing off. Next, inverse cosine, I draw my triangle like this, and I say, oh, is it positive? Yeah, because if it was negative, yeah, okay, so there we go, must be here. And then square root of 2, and then hopefully you recognize it. Root 2, 2 triangle, 45, and therefore pi over 4. That was number 1. All right, let's do number 2, because it's one of those kind of weird ones because it's not a triangle. You can't draw a triangle for that one. So arc cosine is also known as inverse cosine of -1, and I'm going to put it over 1 just because it gives me 2 sides that way. Now I'm going to write cosine of an angle equals -1 over 1. And then I'm going to say, where am I? I can't be a normal triangle because my hypotenuse is the same size as another side. And that means I must be at one of these quadrantals. And that must mean 1, 0, 0, 1, -1, 0, or 0, -1. And which one is it? Well, cosine is x. Sine is which one? Sine's y. Cosine's x. And then what's tangent again? Y over x. Good. So cosine is x. So this x has to be -1. Where is x -1? Well, it's not that one. There are no negatives in any of those. Where is cosine -1? Sorry, x is -1. It's right there. Now be careful. Is that in the area where it's allowed or not? because the cosine is allowed all the way, including both the endpoints there. So yeah, it is allowed there. And what is that spot? Pi. Done. Some people have asked me, how do you know if you're supposed to get angles or sides? If you're doing a problem like this, it gave you the sides, so you must need to give them an angle. If you're doing a normal problem like this, it gave you the angle, so you must be getting the sides. Just try to figure out based on what they gave you, and that'll help you figure out what you need to give back as an answer. All right, let's do another strange one. Let's go to number 18. That one says inverse sine of pi. Is there two? Interesting. Yes, not the one in the bottom section that says write an algebraic expression. It's the one that's right after problem 17. So yes, we need to fix our numbering there. Okay, so number 18 that I wrote on the board here. Don't ever think, oh, I'm just going to go like this and this answer is pi. Okay, first of all, I wouldn't even take it, even if it was right, because I want you to draw pictures, show work for every problem. So I'm going to ask you to start on the inside and say, what's sine of pi? Well, better figure out where that is. Pi's over here. Now, don't fall into that trap that I did before and start looking at this on the outside and say, where are the restrictions? Don't do that, because we're on the inside right now. Finish the inside first. Sine at that spot, well, that's -1 comma 0, and sine is y, and therefore y is 0, and so the answer to that is 0. Now it's a whole new question. Now I can look at the outside and say, what is inverse sine of 0? That means sine of something equals 0. I rewrote it. Is that possible? Now I am on the outside, and now I do have the restrictions, so inverse sine is not allowed, or is only allowed here to here, so I'm crossing off this and this, and sine is equal to 0. That looks like one of those where I can't draw a triangle with a side of 0, right? So it's got to be at one of these three spots. Then is sine is y, right? So I want y to be 0, because sine is y. This is y, right? So y has to equal 0. So 1, 0, 0, 1, and -1, 0. And y is 0. Y is 0 is when it's like that one. So if I was picking, would I want to say 0 or 2 pi on this one? Yeah, why could you not say 2 pi? It's not in the little zone we're allowed to have, not in the range. That's right. This is from -pi/2 to pi/2. That's right, from -90 to +90. And 2 pi is not between -90 and +90. But 0 is. So the answer is 0. Not 2 pi. And by the way, if you put that as 0 degrees, you'd get it wrong, because the answers have to be in radians. All you got to do is throw a degree sign on that, and you've made it wrong. I know it's picky, but it's true. Yes? 0 pi is the same as 0, but it's kind of like not reduced. I would just recommend you don't do that. Yeah, I'd have a tough decision on whether or not to mark it wrong or not, because 0 pi is 0, but it's not reduced, so maybe. So just say 0. Yes? You're right. 0 comma -1 is what I meant to say down there. Let's make sure that doesn't mess it up. Sine is supposed to be the y, and the y is supposed to be 0, so it doesn't. That spot doesn't work anyway, so it's okay. But thanks for letting me know. All right. Any other questions about this one? So that final answer came out right there, because the y is 0, and there's y being 0. So we said 0. All right. Are there any? You know what? I don't want to do too many more of these, because you only have so many, and they don't take that long to do, and I don't want to use up all your practice problems here. So if you need help, please come up and ask me. But we've covered a lot of the weird exceptions. We did a few normal ones, and I test this tomorrow. Do this. Check it with your answers. Take it seriously. Tests are worth 85% of your grade. And this is another one of the trig ones that's not that bad. It's not as easy as the graphing one, but it's not that bad. You can do this. The next couple after that are the ones that are just killers at the end. So try to build up as good a grade as you can right now while it's still reasonable.